Hello everyone and welcome to the latest installment of the IGCSE 0580 Solution Guide series. In this video we will take a closer look at paper 2.2 from the October-November exam period of 2020. So let's dive straight into it. Starting with exercise 1, which I believe doesn't require much explanation, there we just need to translate the word expression of this number into their corresponding digits. Moving on to exercise 2, insert one pair of brackets to make this calculation correct. The best way to describe the approach here would be trial and error. As we can see, if we were to put the brackets around 5 minus 3, consequentially we were to receive the correct result. Moving on quickly to exercise number 3, here we're required to solve the equation 6 minus 2x equals 3x. In order to do that, we isolate x by adding 2x to both sides of the equation, and in a second step we just need to divide both sides of the equation by 5 in order to receive our result, which leads us quickly to exercise 4. Here we have a diagram that shows a triangle drawn between a pair of parallel lines, and here we should find the value of x as well as the value of y. So our approach here would be to employ the following piece of information, which is that angles on one side of a straight line always add to 180 degrees. So in order to receive this angle here, we just subtract 180 from 140, which equals to 40, and on this side over here we subtract 120 from 180 and receive 60 degrees as a result. Finally, to figure out the last angle inside of this triangle, we need to keep in mind that all of the angles added up within the triangle add up to 180. So from there, if we were to subtract 60 and 40 from 180, we would be left with a result of 80 degrees. What is now left here is the value of x. To get x, we need to remember that alternating angles have the same value. So since this angle here has the size of 60 degrees, this means that the value of the angle x needs to be the same, which in this case means 60 degrees. Moving forward to exercise number 5, here we are required to increase 42 by 16%, meaning that we are supposed to perform a percentage increase, for which you can find the formula provided on the right hand side of the screen. After inserting these values into the formula provided, we will receive 48.72 as a result of this exercise. Fast forward to exercise number 6. Here we are supposed to completely factorize the expression 4 minus 8x. The largest common factor of the numbers 4 and 8 is 4, so 4 can be factorized, which leaves us with the final expression of 4 multiplied 1 minus 2x. Next to exercise 7. Here we have a sketch of a triangle which contains the area of 27 centimeters square, whereby the distance of AB equals to 6 centimeters. Provided with those pieces of information, we are supposed to calculate the value of the height h. To do so, we simply employ the formula in order to calculate the area of a triangle, which will be provided at the right hand side of the screen. Since we already know the area of this triangle, we can simply set up an equation and we will be able to find our solution by rearranging our equation for h. So firstly, we can simplify the expression 1 over 2 multiplied 6, which equals to 3. Then a final step, in order to receive our solution, we just divide this expression by 3 on both sides of the equation. We are continuing with exercise 8. Here we are required to calculate the size of one interior angle of a regular polygon with 40 sides. In order to determine that interior angle, we simply need to employ this corresponding formula, whereby the variable n represents the number of sides of this polygon. After substituting n with 40 and using our pocket calculators to determine the result of this expression, we arrive to the conclusion that the interior angle of that regular polygon is 171 degrees. Next to exercise 9, here we are required to solve the simultaneous equations 2x plus y equals 7 and 3x minus y equals 8. Since in both equations the coefficient of y equals to 1 or negative 1 respectively, the best approach to solve the simultaneous equation efficiently would be in solving it by substitution. So in a first step, we rearrange both equations for y, and in a second step we would substitute y in the second equation for its corresponding expression in the first equation. In doing so, we have eliminated the variable y, which then allows for us to determine the value of x. After rearranging this equation, we will receive 3 as a solution for x. Now we can substitute 3 for x in the first equation, which will give us 1 as a result for y. In exercise number 10, we are required to work out 5/6 divided by 1 1/3 without using a calculator. All of our work must be shown and the answer provided as a fraction in its simplest form. In a first step, we need to convert this mixed fraction into an improper fraction. The formula to perform this transformation is provided at the right-hand side of this video. Secondly, we turn this division into multiplication by inverting the numerator and denominator of the fraction 4/3. Then we can simplify the expression 3/6 to 1/2. And in a final step, we multiply the numerators and the denominators and derive to the correct results, which is 5/8. In exercise 11, we need to simplify the expression 2x² multiplied by 5x to the power of 5. In order to simplify that expression, we can use laws of exponents, which you can find to the right-hand side of the screen. 2 multiplied 5 equals 10, and according to the laws of exponents provided, in order to determine the power of x, we simply need to add up the powers of 2 and 5, which leads us to the result of 10x to the power of 7. In exercise 12, we are facing a word problem. Alex and Chris share sweets in the ratio 7:3 in favor of Alex. Furthermore, Alex receives 20 more sweets than Chris. We are supposed to work out the number of sweets that Chris receives. In a first step, it will be our goal to convert those two expressions into two equations, which then provides us with a system of equations, which we will be solving by substitution. The first expression here is a conversion of the statement over there. The second equation here is a translation of the statement that Alex receives 20 more sweets than Chris. Of course, A here represents Alex and C represents Chris. Since the second expression is already rearranged for A, we will do the same thing for the first expression, which can simply be performed by multiplying both sides of the equation with C. Continuing from there, we will substitute A in the second equation with 7/3c from the first equation. As a consequence, A has been eliminated and we will be able to calculate the value for C. To do so, we will subtract 1c from both sides of the equation. And in a final step, in order to determine the number of sweets that Chris receives, we divide this expression by 4/3 or just multiply it by its inversion, which is 3/4. So all of these calculations provide us with the conclusion that Chris receives 15 sweets. Exercise 13 provides us with the following pieces of information. Firstly, the length of one side of a rectangle is 12. Secondly, the length of the diagonal of the rectangle is 13 centimeters. Those pieces of information are translated into this sketch over here, whereby this side here is the side of the rectangle that has the length of 12 centimeters, and this diagonal represents the one described in this statement over here. As we know, all of the angles inside of a rectangle are right angles, which means in order to determine the length of the remaining side of the rectangle, we can employ Pythagoras' theorem. Since this triangle here is a right triangle, you will be able to find Pythagoras' theorem at the right-hand side of the screen. In order to determine the length of x, we simply insert the values that we are provided with into this formula and derive to the conclusion that the length of x is 5 centimeters. Finally, we can now determine the area of the rectangle. In order to determine its area, we simply need to multiply both sides of the rectangle. So in this case, we just multiply 12 by 5 and receive 60. So the area of this rectangle equates to 60 centimeters square. In exercise 14, we are now supposed to work out this expression and give our answer in standard form. The shape of the representation of a number in standard form will be provided at the right-hand side of the screen. In the first step, we need to ensure that both of these expressions are transformed in a way that both are to the same power of 10. And as we can see, 199 is 2 less than 201. So we need to find a way to make sure that this expression over here is represented in a way that shows 10 to the power of 201. Only then we will be able to add up those two expressions. To do so, we will be employing the following trick. Firstly, we will be adding 2 to this expression over here, but what this leaves us with is an expression that's incorrect. So after adding 10 squared to this expression, In order to make sure that our number remains correct, we need to divide all of this by 10 over 2 as well. So if we were to simplify it, we would receive our original number again. As we know, according to the laws of exponent, the expression 1 over 10 squared equals to 10 to the power of negative 2. So what we are technically doing here is adding the factor of 10 squared by at the same time dividing by the same factor. So what we are doing now, we are leaving this part of the expression because now we would have achieved our goal of both expressions here containing the expression 10 to the power of 201. And secondly, we will be simplifying the expression 3 multiplied 10 to the power of negative 2, which equals to 0.03. In a final step, again to the laws of exponents, we can add up both expressions by keeping those powers of 10 and adding up those digits here. Next, moving on to exercise 15, where we can find a sketch of the area of a circle, which we should calculate using the data provided, which is that the interior angle is 60 degrees and the length of the radius 7.5 centimeters. I've provided the formula to calculate the area of a sector here. So what we got to do now is to simply replace the variables for the radius as well as the variable for the angle with their corresponding values. So the radius will be replaced with 7.5 and the angle alpha with 60 degrees. Using your pocket calculator, you should arrive to the solution that the area of the sector is 29.45 centimeters square. In exercise 16, we are dealing with a percentage change, more specifically with a percentage increase. So the selling price of a shirt is $26.50, which includes a tax of 6%. We are ordered to calculate the price of the shirt before the tax was added. So in order to determine the price of the shirt prior to applying the 6% tax, we need to employ the formula provided to the right-hand side of this video. Please keep in mind that 6% is the same as 6 over 100, which is the same then 0.06. With the help of our pocket calculators, we will then figure out that the price of the t-shirt without the tax would be $25. In exercise 17, we are looking at a speed time graph for the first 40 seconds of a cycle ride. And in A, we are required to find the acceleration between 20 and 40 seconds, which means that we are taking a closer look at this part of the graph. In physics, acceleration is defined by speed divided by time. So in second 40, our speed is 4 meters per second, and in second 20, 2 meters per second. So we now need to insert those values accordingly into our formula and arrive to the result that the acceleration between 20 and 40 seconds is 0.1 meters per second square. In part B, we should determine the total distance traveled, and the total distance traveled is represented by the area between the graph and the x-axis. In order to make the calculation of the entire area below the graph line easier, I've subdivided this entire area into 4 sub-areas for the sake of simplicity and convenience. So area number 1 is a right triangle whose base is 10 and whose height is 2. The second area is a rectangle and its width is 10 and its height is 2. The third area represents a rectangle again. So in order to determine that surface area, we multiply 20. So 40 minus 20 equals 20 multiplied by 2. And the fourth and final area is represented by this right triangle. The base of this triangle is 20, its height is 2, 4 minus 2 equals 2. Then we simply add up all of those sub-areas in order to determine the entire area that we can find between the line graph and the x-axis. The total distance traveled here is 90 meters. Let's continue with exercise 18 now. The sides of an isosceles triangle are measured correct to the nearest millimeter. One side has a length of 8.2 centimeters and another a length of 9.4 centimeters. We are required to find the largest possible value of the perimeter of this triangle. So firstly, we could draw up a sketch in order to have a visual representation in front of us. From there, we can derive to the conclusion that in order to determine the perimeter, we need to multiply 9.4 by 2 and add 8.2 to it. So in this example here, A must be 9.4, it cannot be 8.2, since we are required to find the largest possible value for the perimeter of this triangle, and in order to maximize the size of the entire perimeter, that the sides that are isosceles are larger than its base. Since the sides of that triangle are measured correct to the nearest millimeter, the largest possible values for A are 9.45 and 8.25 for B respectively. Now we substitute a and b for those values in the formula that helps us to determine the perimeter and get 27.15 centimeters as a result. In exercise 19 we can find a sketch of a triangle where two sides of it are given as well as an angle of 100 degrees, and we are required to determine the size of the angle x. Since this angle is opposite to this side here, at the end the angle that we are supposed to calculate is opposite to another side that is already given, we can simply employ the sine rule, which is provided to the right hand side of the screen, in order to determine its value. After substituting the corresponding existing values into the formula, we rearrange this entire equation for sine x, and in a final step, in order to calculate the angle, we need to find its inverse. The result of the inverse would provide us with a solution that x is 61.09 degrees. In exercise B, we need to follow up on our result of A. We are here required to calculate the area of the triangle, and we can do so employing the SAS rule, provided again at the right hand side of this video. So since x is now known, we can calculate the size of this angle here, and as we can see, once we are aware of this angle, we can make a case for SAS and thus calculate the size of the area of this triangle. So in order to get this angle, we need to remind ourselves that all of the inner angles of a triangle add up to 180. Then we subtract 100, subtract the value for x, which we have determined in exercise A, which will then provide us with the size of the final angle within this triangle. After inserting all of this information into our pocket calculators, we should receive 11.65 centimeters square as a result. In exercise 22, we have a model of a statue that has a height of 4 centimeters. The volume of the model is 12 centimeters cubed, and the volume of the real statue is 40,500 centimeters cubed. We are now required to calculate the height of the statue. So in order to calculate the height of the statue, we need firstly to determine the ratio between statue and model. To do so, we will be dividing the volume of the statue with the volume of its model, and then figure out its cubed root, since we need to get this ratio down from its third dimension to the first dimension in order to determine the height of the statue, which in this case is 60 centimeters. Exercise 21 is pretty straightforward. Here we are required to differentiate the expression 6 plus 4x minus x squared. So in order to do it for this expression, we need to differentiate each and every summand of this expression. Since 6 is a constant, its deviation equals to 0. Differentiating 4x leads to 4, and differentiating negative x squared leads us to negative 2x. Thus the result for this exercise is negative 2x plus 4. In part B, we should find out the coordinates of the turning point of 6 plus 4x minus x squared. To do so, we need to differentiate the function and set it to 0. As we have already differentiated the function in exercise A, we can simply copy and paste our result over and set it then to 0. Isolating x and then dividing this equation by 2 provides us with the value of x, which is 2. In order to determine the y value of the turning point, we substitute 2 with the value of x within the function, and typing in those numbers into our pocket calculators will then tell us that the y value for the turning point is 10. Exercise 22 shows us a diagram of a triangle OAB and a straight line OAC, whereby the ratio of OA and OAC equals to 2 by 5, and M represents the midpoint of the line AB. Furthermore, the vector OA is represented by A and the vector OB represented by B. In exercise A, we are required to find the vector AB in terms of A and B in its simplest form. So in order to get from A to B, starting from A using the terms A and B, we could simply follow this path here, which obviously leads us to the endpoint B. And since for the first part we are moving from A to O, this path would be represented by the expression negative A. Following from O, moving to our endpoint B, we are traversing OB, which is represented by B. Thus the solution in this case, B minus A. In exercise B, we are required to find an expression for the vector MC in terms of A and B in its simplest form. So in order to get from M to C, we need firstly to move from M to A, and following from there from A to C, which is represented by this expression. Vector MA can then be replaced by the expression of negative 1 over 2 vector AB, since M represents the midpoint of vector AB, and we are moving to the opposite direction, which means that we need to change the sign in front of the coefficient of this vector. In a second step, we need to find a substitution for the expression vector AC. To do that, we can exploit this piece of information over here, which tells us that the distance between O and A consists of 2 parts and the distance between O and C of 5 parts, which leaves AC with 3 parts. From there, we consequentially know that the distance from A to C equals to 3/2 times the distance from O to A. Furthermore, vector OA can be substituted by A. From there, we expand this expression and simplify it to derive to our conclusion, which is that the vector MC can be represented by the expressions 2A minus 1/2B. In exercise 23, we are provided with an expression that should be transformed into a single fraction in its simplest form. In order to do that, we firstly need to figure out the least common denominator between 2/1 and the fraction over here, which in this case is x plus 1. So in order to put all of this into one single fraction, we need to multiply 2 with the expression x plus 1. So 2 multiplied x equals 2x and 2 multiplied 1 equals 2. Minus, and this part is important, 2x minus 1 in parentheses, otherwise we would receive wrong signs. From there we simply expand this part of the expression. The negative sign means that all of the signs inside of the parentheses must be inverted. Thus we receive here negative 2x plus 1, so everything has been inverted, the rest remaining as it previously was. And simplifying this expression leads us to our solution, which here is 3/x plus 1. In 24, we are provided with the information that a line from point 2, 3 is perpendicular to the line y equals 1/3 x plus 1, and the two lines are supposed to meet at the point P. Thus, we are required to find its coordinates. To do so, we firstly need to find the function for the other line, and we can do so by exploiting the formula for general linear functions. So we substitute x and y with 2 and 3. Furthermore, we can derive its gradient since we know that this line that's to be determined is perpendicular to the line that's been provided in the question. The gradient here is 1/3, and from there we can get the gradient of the other line by simply inverting the fraction, which leads us to 3/1, which is just 3, and additionally we need to change its sign from plus to minus. Thus m equals -3. All of this will help us to determine the y-intercept of the other line, and after rearranging this equation to b, we receive its value, which is 9. Therefore, we can conclude that the equation of the other line is y equals -3x plus 9. In order to find the coordinates of p, we just equate both of those lines. Firstly, we multiply this entire expression by 3 in order to get rid of the denominator here. After that, we separate the x's from the numbers and finally divide both sides of the equation with 10 in order to receive x. X can then be substituted by 2.4, and after doing so, we receive the value 1.8 for the y value of p. So the point that we are looking for has the coordinates 2.4, 1.8. In 25, we are supposed to solve the equation tangent x equals 2 for the interval between 0 and 360 degrees. Since tangent x is positive, our solutions will be found in the first and third quadrant. You will find the corresponding visuals to it to your right on the screen. So here, by using our pocket calculator, we receive 36.43 degrees as our first solution. In order to receive our second solution, we add 180 to our solution for the first quadrant, and in doing so we will receive our second solution, which is 243.43 degrees. We have finally arrived to our last exercise of this exam paper. Here we are supposed to simplify this expression. In order to do so, we need to find a means of factorizing the numerator as well as the denominator. For the numerator, things are pretty straightforward. Firstly, we can factorize x from these two expressions here, which leaves us with x multiplied u minus 1, and the remaining expressions are just copied over. As for the denominator, our knowledge about binomial formulas. In a second step, what we can also do is we can further factorize this part of the numerator. Both summands have the factor of 2 in common, so after factorizing we are getting the expression -2 multiplied u minus 1. In a third step we can further factorize the numerator. As we can see, both summands contain the expression u minus 1, so we can factorize this, and the remainder x minus 2 can then be put into parentheses and it will serve as another factor. After doing all of this, we simply compare all of the factors within the numerator and the denominator, and from here it should be pretty obvious that both contain the factor u minus 1, which we can simply eliminate. Thus we receive our simplified solution. I've been your host Marco from Planet Maths. Should you derive any value from my videos, please consider to leave a like, comment and subscribe. Thank you for watching. Cheers.